please hand those up and over now. And if you could have out your note packets from the other day. Let's have you hand those up and over now. And have out your note packets from the other day, please. One thing too, I'll say, it was very interesting getting the feedback from a lot of you as to what worked with the computer thing and what didn't. Because the frustrating part for me is, especially having all of you Enriched kids and having to explain the same like login thing about 100 times. It's even seeming to me like it's a bit excessive and unnecessary. I saw that a lot of you that responded to the poll that was up the other day wrote in that there was like, somebody said it very well, and I don't remember the exact quote, but it was something like, it boiled down to, I learn best when there's pencil on paper. So let's ask this quickly. Who thinks, in general, that you learn better by having to physically write it out? Okay. See, that's the thing I think that a lot of people are missing on it. You can bring them to class every day. We certainly won't be using them every day. I still use it pretty much just to push out information. There's 1 or 2 times during the year where we'll have assignments that are done through it, and exclusively, computer-based. But that's it, so at least hopefully it makes it a little bit better. But have out your note packets to where we left off the other day. So far, we covered all of greatest common factors, double GCFs by grouping. We got all of the sum and difference of perfect squares done. We didn't get perfect cubes done yet. Maybe we can. Let's do this. We'll get this one down now. If you could head over, please, to example 3 on page 6. There's one thing I want you to make sure that you have down to start. Is what a perfect cube number is. A perfect cube is a number that you get by multiplying anything times itself 3 times. Yes, 1 is a perfect cube. It's also a perfect square. But make sure, please, that you can recognize that list of numbers over on the side. 2 to the 3rd power is what gives me 8. 3 to the 3rd power is not 9, it's 27. 4 to the 3rd power is 4 times 4 times 4, which is going to be 64. 5 to the 3rd is 125. 6 to the 3rd is 6 times 6 times 6, that's 216. And 7 to the 3rd is 343. You're going to want to make sure that you're really good at identifying what those numbers are, because we're going to be talking about 2 new factorization patterns that I'm pretty sure that you haven't done before, but aren't that difficult to pick up once you go through and do a couple of them out. Take a look at the first one. We're going to factor a difference of perfect cubes, which means the left side is a perfect cube and the right side is a perfect cube, and there's a subtraction between them. You're going to get a binomial factor and a trinomial factor. Make sure you copy down this formula here, hence the blinking lights around it. So make sure, please, that that finds its way to your paper. You are responsible for sort of, we'll say memorizing it, but it's one of those things where once you do it, it gets kind of easy. So when we're talking about a difference of perfect cubes, that means there's a cube root on the left, a cube root on the right of a binomial with a subtraction sign between them. It will break down into a binomial times a trinomial. Understand the biggest thing that you need to remember, believe it or not, is the signs. So if it's a subtraction of perfect cubes or difference of perfect cubes, the signs across are minus, plus, plus. Now when I do out the first question, I see I'm going to try to factor down m cubed minus 8. So when I see that, the first thing I'm going to do is recognize that the left is a perfect cube and so is the right. What is the cube root of m cubed, or what times itself gives me m to the 3rd power? Just an m. And what times itself 3 times is going to give me 8? So I write those out up above. That's going to help me format what's there. The next thing I'm going to have you all go through and do is list out parentheses for a binomial and then one for a trinomial. List out enough space on your paper for a binomial and then a trinomial. Binomials have 2 terms, trinomials have 3. Your signs going across are going to be minus, plus, plus. If it's a difference of cubes, it goes minus, plus, plus. Those are the 3 signs going across. Minus, plus, plus. So in between the 2 terms in the binomial, there's going to be a minus. And then in the 3 terms in the trinomial, there's going to be 2 addition signs between it. The first thing that we would do is take the left minus the right. So my binomial factor for this would be m minus 2. Now we need to construct what the trinomial factor of this would be. And the trinomial factor of it is going to come from taking the left squared plus the left times the right plus the right squared. So I look at this and say, well, what is the left term? It's an m. I need to square that. So the first term in the trinomial would be m squared. Then I'm going to fill in a plus. Then I take the left times the right. So m times 2 is going to give me 2m. Now I listed it out this way so you can see it's left times right. And then I'm going to put another plus. And then over here I need to take the right term and square it, which would give me 2 squared. Now the first time we'll handle it like baby steps. Can you simplify the binomial? No. Your trinomial, if you were to simplify it down, would be m squared plus 2m plus 4. If I were to multiply this binomial times this trinomial, I would get this binomial here. If I were to distribute the m out to these 3 and the negative 2 out to them, multiply everything we needed to multiply, combine like terms, that's what I would get. Okay? I want you to do this. Follow out, well, we'll start this piece together. 27x cubed minus 8y cubed. Is the left half a perfect cube? Yes or no? Hands up, please, if you can tell me what the cube root of the left would give us. Go ahead. Hands up, please, if you can tell me what the cube root of the right would give us. I want you to see right now if you can follow that same pattern that you had. There's a binomial, leave space. There's a binomial factor and a trinomial factor. Your signs going across, you can fill in as well. If it's subtraction, it goes minus, plus, plus. And it's left, right, left squared, left, right, right squared. See if you can apply that, simplify it down, and then we'll go through and do it together. But give it a try on your own. Everybody should always be getting the binomial factor piece correct. Looking at what's there, for our binomial factor, it should be left minus right, so we would have 3x minus 2y. Hands up, please, if you can tell me what the first term in the trinomial factor is going to be. Go ahead, what are you going to say? Oh, close. And that's, in all honesty, that's the most common mistake. It's not going to be 3x squared. Remember, square the number 2. So that's going to give me a 9x squared, and then there's a plus sign. What's my second term going to be? No, we can do more. 6xy. You can multiply the 3 and the 2. So we're going to have a 6xy and then a plus sign. Hands up, please, if you can tell me what's going to finish this trinomial up. That's great. That's great. Questions on that? Let's bounce down then and try a sum of cubes. Now, you know your perfect cube numbers, hopefully by now. This is a sum of perfect cubes. You can factor down a difference of perfect squares. You can't factor down a sum of perfect squares. You can factor down a difference of perfect cubes. You can factor down a sum of perfect cubes. Now, as we do this out, what I'm hoping that we see is this kind of matches up with this, except for one difference. What changes as we go with the factorization pattern? The signs. Whereas before, this goes minus plus plus, this is going to go plus minus plus. So when I look at this first one, I've got r cubed plus 27. It's going to factor down because we'll take the cube root of the left and the cube root of the right. The cube root of the left will give me an r. The cube root of the right would give me a 3. I'm going to have a binomial factor and a trinomial factor. Hands up, please, if you can tell me what the binomial factor that this would factor down to, what the binomial component of that factor would be. We'll wait for 5 of you. We've got 1, 2, 3, 4. You want to say please? Terrific. Now, this is the one that's going to be difficult. Give yourself space now, please, for a trinomial. And in that trinomial, there's 3 terms. You can fill in the signs. It goes minus plus there. It goes left squared, left, right squared. Let's see if we can get 7 of us that can give me a good guess as to what you think that trinomial factor would be when you get it. We got 1, 2, 3, 4, 5, 6. Who was 7? That's right. So if you can do that now, you can handle that last one. So go through, please, and do that last one. Do B, please, on your own right now. And by the way, what's the first thing that we should always be looking for? Look for a GCF every single time. And I get lazy sometimes, and I don't say it, but we're always looking for a GCF in step 1. So go through, please. Handle B. Looking at what's there, I list this out. This is going to factor down. This is going to be 3z here. This would be a 5. So it's going to be a binomial. Trinomial, it's a plus. So it goes plus minus plus. The binomial is going to be 3z plus 5. Left squared would be 9z squared. Left right would give me 15z, so minus 15z, and then right squared would give me 25. It's important to denote this. The remaining trinomial that you get should not factor down. You can't go further after applying this pattern. Unless there was a GCF initially that you didn't take care of. Now, questions on those? Go through right now, please, and do out question C on your own. So looking at what we've got to start, I list out what the cube root of the left is and the cube root of the right, and I need to make sure that it's a sum. So now once I get to here, I'd say, well, there's a binomial, and that's going to be 5t plus 6x squared. Who can tell me what the trinomial is going to be for this? Go ahead.
25t squared minus 32s squared plus 36s.
There you go. X to the fourth. The biggest thing is, and you're going to find this happens a lot, I'm a process person, so I need to see these little components listed out when I'm doing it. It makes it easier, especially when the questions get more difficult. It helps so we don't lose people. Looking at what we've got in question E, you're going to go through, and again, what factorization pattern does this match? Well, it's not a difference of perfect squares. There's no GCF as it currently stands. So what I want to go through and see is, well, is this a sum of cubes? Does that work? Can I take the cube root of the left and the cube root of the right? You coming? Can you? Who thinks you can? 1, 2 of you, 3. What's the cube root of the left? Because x plus 2 cubed gives me the quantity x plus 2 cubed. And then t cubed, well, the cube root of that we get. So now I've got to format this, and it's going to get awkward because there's a binomial. For some reason, we shut down if it's not a single term. That's the same exact process that you did before. It might require another step, maybe a little bit of simplification, but that's it. So what I need you to do now is list out space and give yourself adequate space for a binomial factor and a trinomial factor. Now the binomial factor is actually going to have sort of 3 parts when we list it out. So I go in and leave space and put since it's a plus, it goes plus minus plus. I'm going to take the left plus the right. So my binomial factor is going to be the quantity x plus 2 plus t. And remember, brackets are just there because they're secondary parentheses. Now I look at what I'm going to have on the right. And this is where it's going to get a little bit awkward. Who feels confident in taking a guess as to what you think this would be? I'm not asking you to expand anything. But what do you think that the trinomial factor on this would look like if we expanded it out? No takers? 2 of us? And Beth, what do you want to say?
Times x plus 2 squared.
So far, that's good. Left squared. Keep going. Careful. Before you say distribute, what's the sign? You didn't tell me what that sign is.
Minus.
Okay? So there's minus. Those 2, and then what are you going to have at the end? Okay. Now, you all are pretty good. Take a look at that first binomial. This first set here, I'm going to look to simplify this out. There's nothing to distribute in front. That's just there sort of for formatting issues. This first binomial factor is actually a trinomial. It's going to be x plus 2 plus t. The next thing that you're going to do is you're going to take the quantity x plus 2 and square it. Now, this is one thing that I don't have much patience for, is when we screw this up, because there's always a subset. It doesn't happen as much in Enriched as it does in Reach. When we see something like this, you really, really need to make this link. When we're talking about the quantity, is it x plus 2? Yeah. Being squared, if something is squared, this does not equal x squared plus 4. You have to remember to list the binomial out twice. Now, this is where, and I get yelled at because the guy that runs the math show in Webster, he loves that rectangle thing that you are, box thing that you did, where it looks like you're making a fence or something like that. Whatever. I am a FOIL person, which means first outer, inner, last. Now, so when you see it, that's how I do it. I am not prejudiced against many things. I am prejudiced against. Is there a name for it, like a rectangle of fun or something like that? They call it like a box. The box. Okay. We don't. I don't. You won't see me do a box. So what we're going to do is we're going to take our first terms. FOIL means first, outer, inner, last. My first terms multiplied together are these two here. So my firsts give me an x squared. My outsides, that's the O, is x times 2, which is going to be 2x. Then my insides is going to give me another 2x. And then my lasts is going to give me a 2 times a 2 for positives. So that's going to give me 4. Now, we're working off of the assumption that you can do this in your head. You can be a mental math all-star with it. And we're hoping that you understand you're taking the drastic step of combining 2x and 2x in your head. So this is going to become x squared plus 4x plus 4. Now, I like distributing monomials to binomials, but some of you go the other way. It really doesn't matter. Make sure that the negative is there, though, because you need to understand that what you're distributing out here is a negative to this, and then multiplying it by t. I would view it as a negative t getting distributed out. It all depends on how you write it. In any case, our next two terms are going to be negative xt and negative 2t. And then my last term at the end is going to be a t squared. Is that one an extension question? Absolutely. Absolutely. Wouldn't even bother putting out on paper in Regents. Questions on that? All right. Let's do this. And here's the factor patterns that we've sort of touched on. I really don't go too much into perfect square trinomials because it's an unnecessary pattern to recognize. That's why we're not doing this little section here as example 2. Let's please bounce over to page 3. These are the ones that you probably started doing that you were able to, that they identified you as enriched in the beginning. If you're asked to factor down a trinomial, again, you're looking to say what times what is going to give me the expression that I've got. We're looking to break things down into its components. So, in order to factor this, what we're looking to say really is, I need numbers here that multiply to negative 35 and add to positive 2. Now, that should be easy, but so you all see the process. I know sometimes we've got some people in the building that for some reason show people even how to do this in a calculator. They type something in and make find matches and tables. Stop. I need you to be able to tell me two numbers or a factor pair that multiplies to give me 35. There are two factor pairs of 35. Hands up, please, if you can tell me one of them. Which one do you want to say? 7 and 5, and give me the other factor pair. 1 and 35. Okay, so I'm listing those out. I've got 5 times 7 is going to give me a 35, and I've got 1 and 35. Now, I need to get a 2, and it needs to be positive, but when I multiply these values, it's going to have to give me a negative 35. So, what I list out to start is, this is going to fit, by the way, there's no GCF, but then I forgot to say that. There's no GCF. I list out two binomials. On the left, I'm going to have out an x times an x, and then I'm going to put after that numbers that are going to add to positive 2 but multiply to negative 35, and we always start with the multiplication first. So looking at what's there, I would need the 5 and the 7, and make sure you're good with the signs. So you could go through and fill in the 7 and the 5 on the right, and then we say, well, what gives me what? Well, I need to get a positive 2. So I need to make the 7 be the bigger one and the 5 the negative. So this would factor down to the quantity x plus 7 times the quantity x minus 5. That should be automatic for us. Go through right now, please, and do A and B underneath that. I need to get a 1 from this list of factors. So this would, and a negative 30 when I multiply them, so this would be negative 6 and positive 5. The quantity t minus 6 and the quantity t plus 5. Questions on that one? Next one up, I need, there's no GCF, w squared plus 12w plus 32. Hands up, please. Can you tell me what that one's going to factor down to be? We've got 3 people, 4, 5, 6. What do you want to say, please? Yeah? Those are the ones that we're assuming you can do automatically. How about, for example, 2? Hands up, please, if you can tell me what that's going to go through and give you. Remember, well, you can tell me what example 2 would factor down to be. Remember, our factor pair is 7, right? You've got 1 and 7. 7's prime.
M minus 1 and M plus 6.
All right, let's give it, careful. Well, let's watch this. M minus 1 and M plus 6.
And what M 7, sorry.
7, all right. Watch what happens. Looking at what's there, you always need to think of it in terms of the opposite inverse operation here. So we can go through and expand this out. So let's FOIL it and see what we get. If I do this out, I get m squared. Then on the outside, I would have 7m, and the inside is negative 1m. So I get a 6m, which is right. So far, so good. And then I multiply 1 and 7, and I've got a positive 7. Is everybody good with that? What's wrong with what I just said? It's negative 7 that we would get at the end. So does this factorization work? No. So now we're out of options. We had 1 and 7 and they don't work. This doesn't factor. This is prime. Understand that primes do happen. Now, you always, though, need to be thinking of breaking it down, either going from FOIL to the trinomial or the trinomial to the FOIL. So looking at this next one, I'd say, all right, I've got to factor this trinomial. Now it's got 2 variables in it. The process isn't that different. It's not different enough for you to be concerned. Looking at this, there's no GCF. Remember, these you could take out a 2 and an A from, but that's not in these first, so you can take out an X, but it's not common in everything, it's not common. So I'm going to list out 2 sets of parentheses. And if I'm looking to break this down, in this first spot here, the values that I multiply together here and here, these 2 terms have to give me that. These 2 terms at the end have to give me this negative, I have choice, but negative 16a squared. So I'm going to start off with what's going to get me to the yellow, because there's only one way I can get an x squared by using those yellow positions, and that's by having an x and an x. Now, I need to find ways to get to 16a squared that are going to add to 6a. Well, 16a squared, so I'd list this out maybe in the margin or something. Who can tell me one factor pair of 16a squared?
I said 2A and then 8.
All right, so it's going to have to be 2a and 8a. Who can give me another one, please, that you could use to get to 16a squared? 4a and 4a. And there's another one that we haven't gone through and listed out yet. Who can tell me the last one?
61.
There you go. Now, from there, we need to find a way that I can get a positive 6a squared. And that's a negative 16a squared at the end, is that right? Okay. So, I know since it's a negative value at the end, the signs are going to have to be mixed, because the only way you can get a negative is to multiply a negative and a positive or have different signs. Now, to fill this in, I need to find which factor pair I'm going to use. Those don't work and those don't work. I'm left with a 2a and an 8a. I need to get a positive 6a, which means This needs to be positive 8a. This would have to be negative 2a. But before we go through and congratulate ourselves, let's make sure it actually works. So let's do the FOIL process. And we're not going to write it out. We should be able to walk ourselves through it. First terms multiply together. X times x is going to give us x squared. The outside terms would give me negative 2ax. The inside terms give me 8ax. They're like terms because they've got the same variables attached to them with the same powers, and that's going to get us to a 6a. And then at the end of this, I go through and multiply these two together. I got 8a and negative 2a, and that's going to give you the negative 16a squared that you were looking to have. Questions on that? All right. Hopefully those are a little bit easy. Take a look at the next one. Hands up, please. You can tell me what the first thing that you see in 4 would be. We've got 1, 2, 3, 4. You need to be vigilant. What do you want to say? All right, so let's factor out a GCF of 16y. And when we factor out that GCF of 16y, that's now what I'm left with. Y squared minus 2y minus 3. So we got that done. The next thing that I would need to do is say, all right, well, can we keep going? Look at the remaining trinomial. Hands up, please, if you can tell me what the remaining trinomial will factor down to be. The y squared minus 2y minus 3. Matches the factorization pattern we did with question, with example 1. We got 1, 2 people that can tell me. 3, 4, 6. What's that?
Finding the y minus 3 times y plus 1.
Don't forget the GCF that you took out in the beginning. We can't tell you the number of kids who miss a very good grade because this will result in you missing an answer if this was to be solved. Taking a look at the next one, this is probably the toughest type that we're going to do. Looking at what's there, we discussed this before. Now, the fact that the part about these that are different, we can't automatically assume things, is now our lead coefficient here is not a 1. I'm still going to go through, though, and try to factor it down. This is why we do math in pencil. We would go through, and I'm going to start off with this pairing here. I get my 2 sets of binomials, and I'm going to have to recognize that this and this need to multiply to give me this. I also know at the end, I'm going to have to take this value times this value, and when I multiply those together, I'm supposed to get that one. The arrangement of them is going to cause me to get the middle term. Now, looking at 12, you're going to actually like to work with a number like, let's say, 43 as opposed to a number like 4. You're going to like working with 7. You're going to like working with 11 and 13. All of those numbers that are prime are very easy to do. 12 is not prime, it's composite. So what I'll start off by doing, do this first, because I'm going to be erasing. The first thing that I would do is list out on the side the factors of 12. What can I put in these positions to give me 12r squared? Well, I could have 12r and r. I could go through and have 3r and 4r. I could also go through and have 6r and 2r. Is there anything I'm missing? And then at the end, you've got 2. Oh, by the way, the signs are going to have to be mixed, so 1 plus is going to have to be there, and 1 minus is going to have to be there. And then at the end here, I need numbers that multiply to 2, so we're kind of lucky. 2 has only 1 in itself as factors. Now, all you're going to be doing is toying around with which one goes where. You're going to FOIL it out in your head to see which one actually will go there. So, I'd start off and say, let's try. So I'll start off and say, all right, the 6R we'll put here, the 2R I'm going to put here. I've got a plus and a minus that I need to ungroup, so maybe I'll try a plus here and a minus here. And I've got to plug in a 2 and a 1. So I got a 2 here and let's say a 1 here, right? Now, let's FOIL that out and see if it works. So, to start, I've got 6R and 2R. 6R times 2R is going to give me 12R squared. We're good. Outside terms give me negative 6R and then positive 2R. Negative 6R and, what did I miss say? What should that inside give me? 4R. So what do I get when I have negative 6R and positive 4R? What would my middle term be? Negative 2R. Did that work? No. There's a reason before I did this that I knew that this arrangement would not work. And I would never have you guess this. Some of you will see it and some of you have to do it a lot. Take a look at what's there. There's something about that first factor that the first factor has that the final answer doesn't. Does anyone see what the first factor has that the final answer doesn't? So something can't show up in the answer at the end. It's not there. Is there a GCF for the entire expression? The original? No. Does our factor have a GCF? Then it's not going to be. Our guess did, and that's why it didn't work. If I can factor something out of here, that means the original should have a GCF. So I know that there's certain guesses that I'm not going to be taking. Let's try, we'll mix it up now, and let's try this arrangement and see if it works. So the first one, it didn't work. Next one, we still have 12R squared. On the outside, I now have negative 12, and the inside I've got 2. Is that going to give me negative 5? No. So this arrangement is not going to work. All right. So now, I'll take those out. I'll take the 1 and the 2 out to the side. I'm probably going to want to ditch working with 2R and the 6R. Who can tell me? Well, let's say this. Go through right now. You take a guess. And see if you can get one that works. You take the guess. And please understand, when I reference this type, like we say difference of squares or GCF or sum of difference of cubes, I go through and call this way of factoring guess and check, because you literally take guesses and check to see if they work. Some guesses are more educated than others. The more you do it, the quicker you'll see the pattern, but it reinforces the relationship between the FOIL and the trinomial. Go through and let's see if we can get that done. Take a guess. If it works, great. If not, that's why God invented erasers. We suck it up and move on and try another one. Let's see if we can get 5 people who can tell me the factor pair that works. Factorization. We got 1 that sees it, 2, 3, 4, 5. In the back, what do you want to start this off with? 3R minus 2. All right, so we're going to put a 3R here. All right, so you want a 3R here. That means you're going to put a 4R over here. And I'm sorry, if I heard you right, did you say minus 2? Okay, so we've got a minus and then a 2. That means over here I need to have a plus and a 1. All right, now let's try and see if that works. That's my guess. So when I'm doing this, this gives me the 12R squared I'm looking for, which is terrific. On the outside, I have 3R, and then the inside is negative 8R. What's 3R minus 8R going to give me? The negative 5, and then at the end, does it multiply to negative 2? Yeah. So that's what our answer is. You're literally going to be taking guesses until you get the one that works. There's no shortcut around it. The more you do, the more educated your guesses will be. You are going to hate seeing a 12 in front. You're going to hate seeing a 6 in front. You're going to hate seeing a 10 or a 20 in front. You would love to see a 19 in front. Why would you rather see a 19 in front than a 12 or a 6?
Let's things that you can choose.
Yeah, there's less factor pairs. Perfect. What's the only factor pair for 19?
119.
There you go. There you go. So now, let's go through and try this. Go through on your own right now, please, and do out this next example. And I already filled in the stuff that I know. I know I'm going to have an X in the beginning. This one is easier than the last one that you did. Go through and do out example 6 right now. Hands up, please, when you can tell me. We'll wait for 8 of us that can give what this factorization is going to be. We've got 1, 2, 3, 4. 5. Listen, and let's make it very clear. You're going to make attempts that don't work. There's going to be times that you're not successful. That's fine. Put a line through it and move on. You've got 1, 2, 3, 4, 5, 6, 7. 1 second.
It's 3x plus 1.
And then? Let's multiply this out. 3x times x is going to give me 3x squared. That takes care of my first terms. Now the outside terms are going to give me a positive 6x. The inside terms give me a 1x, and then the last terms give me a 2. Does that match what we needed to? There you go. You're good. Again, if you're going to do it, it's not going to work sometimes. And I had down 2. That outside-inside, the arrangement's going to cause you either to get the right or wrong middle term. Questions on that one? Let's see if I can get rid of it. When I do this out, the same process is going to apply. I'm going to list out 2 sets of parentheses. What I have in the beginning will be pretty much the same, although I'm very irritated. I'm wishing that that was a 23 or a 91 instead of an 18, because for my factor pairs in the beginning here, I could have a 1m and an 18m. I could choose from a 2m and a 9m. I could have a 3m and a 6m. Is there anything I'm missing? No? Then we've got negative 12, so I know that there's going to have to be a plus sign and a minus sign. And then over at the end here, factors that multiply to 12x squared, not 12, but 12x squared. The values I could have would be x and 12x. What else can we do? We've got 2x and 6x. And then the last one that we've got to get down is 4 and 3. So, is there a lot of arrangements? Yeah. Those two, please. You tell me. We'll wait for 7 of you. I think that there's 18 possibilities. The more you do them, I can assure you, the better your guesses will become. Because, by the way, we say that there's 18 possibilities, but there's not really. Because if I put a 1 and an 18 there, next to the 18, I cannot have something that shares a common factor with 18. So if that's the case, if the 18 is there, I can't have a 12, 2, 6, or 4 next to it. Why? So you have a GCF of 2. So all of a sudden, you go from 18 possibilities. If you're not paying attention, if you're just in auto drive, you go down from 18 possibilities to, I think, 5 or 6. I think there's actually 4. How many of you have gotten to what our answer is? We've got 2 of you. We'll wait for 6. 3. Thank you. Terrific. Terrific. 4. Again, you're going to try and fail. You have to keep trying. Your guesses will get shockingly better. And your mental math skills are foiling binomials in your head and they get really, really good. Word 6, what do you want to say yours is?
Can I say 2m minus
Oh, okay, so sorry. You said you wanted it to be 2m here, and that means over here you're going to have what?
9m
Good. And then, which sign did you put here?
minus
Okay.
3x
Okay. And then over here would have to be?
plus 4x.
Notice, by the way, there's not a common factor here because this doesn't have a GCF. So let's do this out. We've got 9 and 2, so that's 18m squared. The outside terms would give me 8. Oh, sorry. Yeah, that's 8. Outside would be mx. And then my inside would be negative 27 mx. Does that get us to where we need to go? Because what would we have? We'd have the 18, or 19, excuse me. Questions on that? Looking at this next one, I see this, and right away I'm discouraged by what's there. What's different about this one? Hands up, please, and tell me what's different about it so far. I get how it's different first. What do you want to say?
There's a negative 3 instead of a positive 3.
What can we do to make this a heck of a lot easier? I'm going to factor out a negative 1 right from the start. Good morning. Hey, how are you? Yeah. Hang on. Is there a Sarah Leonardo? Yes, she's here. Okay. Okay. Yep. Thanks. There's a new schedule for you apparently down in the guidance office. All right, what would we do from here? Well, the next thing I do is I'm going to look to factor this down. Just remember, you've got to keep that negative 1 in front. So this will be our last one for today. Hands up, please, when you can tell me what that remaining trinomial is. And by the way, I'm happy to see this. Because what's in front? 3. You want the 3. 3 is prime. 2 is prime. You're going to hate seeing a 4. You'll love 5. You'll hate 6. Love 7. Hate 8. We got one person that can tell me what this breaks down to. 2, 3, 4. 5. What do you think?
3x plus 2 and x.
There you go. There you go. Now, here's one thing, by the way, a way to, well, I guess, how would you check your answer? Expand it out and then multiply by negative 1. I mean, you should be able to know whether or not you did them right or not.
I didn't see this from that.
Now, we're going to set this to the side, and we're done, I guess, with this for the day. Your job, let's see this. Hands up, please, if you were successful in making your Math Excel account. Nice and high, so you have a good, okay. If you weren't, there's no assignment, I don't think, in there waiting for you, is there? I'm going to assign you by the end of the week an orientation thing on there, just so you know how to input your answers. But everyone in here, is anybody not able to get their Math Excel sign up done? Okay. I'll send it out as a remind message today to go through once I've activated it. But the orientation chapter, I guess, will be your homework for over the weekend. When we come back, you need to make sure that you're able to do the factorizations that we've done. There's examples after each type. Make sure you can do them and you can understand them. You'll have another assessment waiting for you. By the way, who here has the Infinite Campus app on their phones? Okay. Did they are you still able to get in, or do they reset your passwords every year? You reset them. Make sure, please, that's another thing. Make sure you're able to log into your Infinite Campus. You already have a grade in there from Assessment 1. Assessment 2 will be in there shortly, okay? So do your best. Thank you very much. If you want to leave a minute or two early, honey, to get that schedule thing. You got a calculator, set them back on the side. Thank you. Yeah, come on over. Let me do this.